Question number 1. What's the probability of B complement? B is whether they eat breakfast or not, so the complement is opposite. So this is when the probability of them not eating breakfast, okay? So eating breakfast was 300, not eating breakfast was 295 out of the 595 people, okay? So that's probability of not eating breakfast. Okay, complement means opposite. Okay, part B, find P female and doesn't eat breakfast. Okay, female and not eating breakfast would be female and BC. Okay, so if they're female, okay, we're looking at this group, and not eating breakfast would be 165 out of the 595. Part C, probability of female or not eating breakfast. Okay, so here's the difference between the and the or. So this, in part B, this is an and statement. These people did both. They're female and didn't eat breakfast. Okay, now we need the or. Okay, so females would be these two groups, and not eating breakfast would be these two groups. So I want to add these together. Okay, so that would either be, the 110 plus the 165 plus the 130. Okay, which would be, let me grab my calculator. Would be 405 out of the 595. Okay, or another way to do that is we can do the females plus the not eating breakfast minus the and of those, right? Okay, so the females were 275. The not eating breakfast was 295, and then we can subtract the part that the 165. Okay, so that also gives us the 405 out of the 595. Okay. Okay, so for number 2, we're looking at the Titanic. Some passengers got off the ship in lifeboats, but others died. The two-way table gives information about who survived and what class they were in. Okay, so were they in first, second, or third class? And were they survive or not survive? Okay, so suppose we pick somebody randomly. D is whether they died, and F is whether they were first class. Okay, so if I want F complement, so this would be the probability they're not first class. So first class had it 197, so not first class was 94 plus 151. Okay, so not first class would be these two groups. Actually, it'd be easier. I want to add all these, whether they survived and didn't. So we add this group together plus the 167 plus the 476. Okay, so altogether there were 888 people out of the, okay, we got to add these all together. Okay, so the total altogether was 1207. Okay, so there were 888 people in second or third class out of the 1207. Okay, the next one says not first class and survived. Okay, so if they're not first class, that means they're second and third class, and they survived. So yes, they survived. So I want to add just these two together. So that would be 245 out of the 1207. Okay, not class first class or survived. Okay, so here we see the or statement here. So or means not first class. Okay, so it'd be these groups. Or survived. Okay, so yes, survived. So I'm looking at all these people. So I'm looking for everybody except this. Okay, so if they're not first class or survived, the opposite of that would be that they're first class and didn't survive, right? Okay, so I'm looking at all these two, all these others. So I can add all these together, Or I can just think of the 1207 minus the 122, and that gives me 1085 out of the 1207. Okay, so that's question number 3. Sorry, number 2. Okay, number 3, the December 2013 Pew Research Center polled adults who use internet and found that 71% use Facebook, 17% use Instagram, and 16% use both. Suppose we randomly selected a person, what's the probability he or she uses Facebook or Instagram? So probability of Facebook or Instagram, okay? So when you think about your general rule, we can use the probability of Facebook plus the probability of Instagram minus the probability of Facebook and Instagram, because we don't want to count them twice, right? We don't want those people that overlap. So Facebook had 71%, Instagram had 17%, and 16% used both. So I don't want to count that 16% in both of these two categories. So that's interesting. There's only 1% that only used Instagram and not Facebook. Okay. Anyway, so that would be 0.72. Number 4 is then asking us to make a Venn diagram of this. So there is some overlap, so I'm going to overlap the circles. There was some and, right? There was 16% that had both. Let's say this is Facebook and this is Instagram. So Facebook, the whole thing is 71%. So 71% minus the 16% that were both left us with 55% of the people were only Facebook. And in here Instagram was 17% and 16 used both, so I know that only 1% of the people use only that. Okay, and then I have all these together is 71, so there'd be 28% of the people. 72 is everyone, right? So not using Facebook or Instagram would be 28% of the people. Okay. Part B, find the probability the person uses Facebook but not Instagram. Okay, probability of Facebook but not Instagram. Okay, so Facebook but not Instagram would be 55% of the people. Okay, number 5. So in 2015, it was 57% of the House of Representatives were Republican, and the rest were Democrats. So 100 minus 57 gives us 43%. Okay, said 19% was women. Okay, so 19% were women, which means 100 minus 19 would be 81% would be men. And it said that 36% were men who identified as Democrats. So men and Democrats. Okay, so there's kind of our information. So suppose we selected some person at random. What's the probability the person is a male or a Democrat? So probability of male or Democrat. Okay, male or Democrat. So remember, we can think probability of male plus probability of Democrat minus the probability of male and Democrat. Okay, so that's sort of our general rule. So males, okay, males were 81%, Democrats were 43%, males and Democrats were 36%. Okay, so 81 plus 43 minus 36 gives you 88%. So 88% of them were either male or Democrats. Okay, the next one is then asking us to make a Venn diagram out of this data. And they do overlap. Okay, our two events are M for male and D for Democrat. Okay, so let's start on the inside. Male and Democrat was 36% of the people. If we go only males, okay, males were 81%. So 81 minus 36 gives you 45% that were males that were not Democrats. And then Democrats made up 43%. Okay, if we have 43% minus the 36% in the middle, that left 7% that were Democrats that were not male. Okay, and if I put all this together, 45 plus 36 plus 7%, that gives us 88%. So if the others would be 12% who were not male and not Democrat. So basically there were 12% that were female Republicans. Okay. Okay, number 7. So they asked a sample of 2,024 adult cell phone owners in the US and their age and what type of phone they had, iPhone, Android, or other. So here's what they have. So we have different types of phones and their age groups. Okay. So what's the probability that they're not 18 to 34, so we're not in this age group, we're over here, and does not own an iPhone. So they're not here and they're not there, which means they have to be in this area. Okay, so I can think about this. I can add the 189 plus the 100 plus the 277 plus your 643. Okay, so those groups are not iPhones and not in this age group. So that would be a total of 1209 out of the 2024. Okay. The next one, what's the probability that their age, this age group, or owns an iPhone? This group. Okay. So it'd be all these people are in that age group, and all these people own an iPhone. So I want to add up all those together. So 169. Well, okay, let's approach it this way. So I want this one or this one. So let's do iPhones. Okay, so let's actually do the age group first. That would be 517 out of the 2024 would be the age group people, plus the iPhone people would be 467 out of the 2024. But notice I in this group and this group I added this 169 twice, so I have to subtract the 169 out of it. Okay, so 517 plus 467 minus your 169. Whoop, what did I do wrong? Okay, is 815 people out of the 2024 people. Okay, so that would be this plus this plus this plus this plus this. Okay. Okay, the last question, number 8, is asking us to make a two-way table. So Jack and not a Jack, and red and not a red. Okay. So how many Jacks are red? So here's all your cards. Here's all of our Jacks, and the Jack of diamond and the Jack of heart are both of those. So we have 2 that are Jacks and are reds. How many Jacks are not red? So the Jacks here, 1, 2 are not red. So there's a total of 4 Jacks. Okay. How many red cards are there total? Okay, so red cards, there's 13 diamonds and 13 hearts. Okay, so that makes 26 red cards total. Okay, so there's 26 total red cards. If there's 2 of them that are Jacks, that means there would be 24 that are not Jacks. How many are not red? We have 13 spades and 13 clubs. So that makes 26 as well total. And if 2 of them are Jacks, that means there's 24 of them that are not Jacks. So there's a total of 48 cards that are not Jacks, and total of 52 cards total. Okay, so that's part A. Okay, part B. Okay, we want to find probability of getting a Jack, and then also the probability of getting a red card. Okay. So I assume you know these are what we're talking about, right? All these different cards. Okay. That's what the jacks look like. Actually, I don't know if you know this or not, but some jacks are one-eyed and some are two-eyed. It's kind of interesting. I didn't know that until a couple years ago. So there's a two-eyed jack, right? Two eyes looking, and there's a one-eyed jack. Anyway, kind of interesting. Besides the point. Okay, probability of it being a jack. Okay, jacks, there's a total of 4 out of the 52 cards. And reds, you know, half of them are red, right? Okay, so we got half are red and half are black. So we have reds, we have 26 out of the 52 cards. Now, ideally, I would like you to simplify. You get 1 over 13 and 1/2. Okay. Okay, part C. Write the event red jack in symbolic form, then find the probability, okay? So what's the probability of something being red and being a jack? Okay, or you could also write this as red and means the union jack. Okay, red and jack, there were 2 of them out of the 52 cards, which is 1 over 26. Okay, and part D, explain why this is not equal to that. Okay, probability of jack and red is not the probability of jack plus the probability of red. I'm sorry, this is intersection, right? This is union. Got that mixed up there real quick. Okay, so union. Okay, this is not true because they are not mutually exclusive. We have jacks that are red, we have jacks that are black. Okay, so we have there's a red jack right there. Okay, so if they didn't overlap, then I could say it's just probability of jack plus probability of red, right? But when I count all these cards here, how many are red jacks, right? So there's jacks and reds, and there's 2 of them that are red jacks. So I would overcount them. I would count these red jacks in both the jacks and the red. So I'd have to. It should be the probability of jack plus the probability of red minus the probability of jack and red. Okay, that should be how it is. So jacks, there are 4 of them. Reds, there are 26 of them. Okay, so if you think about this, there's all these cards here, right? Of the jacks, there's 4 of them. Of the reds, there's 26 of them. But I counted these 2 cards twice. These 2 cards are included in the jacks, and they're included here, but they're only 1 card. So I got to subtract those 2 repeats out. Okay, so there really just are 28 of the 52 cards that are either jacks or reds. Okay, and so if I divide that, that gives me 7/13. Okay, that's the homework. Come ready to class with some questions.